Hi guys, let's try one more problem. Determine the current in each branch of the network shown in figure by using Kirchhoff laws. So the network is shown at here, a combination of resistors and connected to a voltage source of 10 volt. So if you notice in this one, current value is not given. So how the currents are divided? So that thing we need to do that. Suppose from 10 volt source through a 10 ohm resistance, if I take I is the current is flowing. Now the same I is also flows across this branch, and at junction A this I current gets divided. Suppose in the arm I1 is current is flowing, and in the arm AD I2 current is flowing. So same I1 current is flowing in the arm A to B, so here also comes I1. And at junction B again this current I1 will divide. Suppose if the arm BD, if I take current I3 is flowing, and through the BC the leftover current, it means I1 minus I3 is the current is flowing. So here my suggestion is that no need to increase the different numbers. You need to apply here the branch rule, junction rule. Current entering a junction should equal to current leaving the junction. So instead of you take I1 minus I3, if you take I4, so you won't get any result. So I1 current at junction B is divided as I3. If B to D branch, it divides I3, and rest of the current I1 minus I3 will be flow through the branch B to C. Now come back, in the branch B to D the same current I3 is flowing, and at junction D, so this current I2 from A to D and current I3 from B to D, they will add up because they are entering the junctions, and they are leaving to the junction D to C. The current at here, this is I2 plus I3. So at junction D, the currents which are coming from A and the current which is coming from B, they will be add. Now come back to junction C at here. Now the same current is flowing through 5 ohm resistance. Here it is I1 minus I3, and here it is same current I2 plus I3, and if we can add up, so we can end up that I1 plus I2. It means the same current I will flow back. So the same current what we started with I, what I started with I is the current. At here A is divided, I equal to I1 plus I2 at junction A. But at junction C, it is I1 minus I3 plus I2 plus I3. And if you can add up, I3 gets cancelled, that is I1 plus I2, which is nothing but I. So this is how we divide current across the junctions. So here at junction C same current. So finally I got the same current back through the cell 10 ohm resistance. Now after the division of currents, we need to consider the loops. So here I prefer to consider these loops A, B, D, A. So this is one of the loop. And here one more loop, I can take that B, C, D and B. There is one more loop. And you can take the outside loop, that is A, D. So this is the loop. I am taking A to D to C again to A. Now we need to apply our Kirchhoff sign conventions to each loop. Suppose if I take the sign conventions, so I'm encouraging you, you should remember sign conventions. You want to get the sign conventions chart or help during the examination time. Take the loop. So if I take the loop B, A, from the loop A. So if I start from 4 ohm resistance, so 4 ohm resistance current is flowing. So current direction and my travel direction, they both are same. If they both are same, I should take that as negative. So that is minus 10 I1. And when it comes to that same loop, when it 5 ohm resistance across, I3 is current across 5 ohm resistance. And my direction of traveling, current direction, they both are in the same direction. Again, if it is in the same direction, we should take that as negative. So that gives to me minus 5I3. And when it comes to one more 5 ohm resistance across A to D branch, so my direction and current direction across the branch, in this case, it's both are opposite. When it's opposite, we need to take that as positive. So finally here I can get plus 5I2 which equal to 0. So if I write this expression properly, so I will take the minus common and I can write it as 10I1 plus, I will write the I2 first, so here it is minus I2 plus I3, 5I3 which equal to 0. So this is the first expression from the loop ADBA. Now take the second loop. Now if you take the loop, let me grab some space. Now this time I am considering loop B, C, D, B. So I am going to work out in that loop. Now in that loop across the 5 ohm resistance, the current direction, my direction, they both are same. So you can take that as negative. So minus I1 minus I3 of 5, and across 10 ohm resistance in that loop, my direction of traveling and current direction, in this case they both are positive. So here I can take that plus, so the current in that arm, that is the positive, plus I2 and I3 of 10 ohm, and across the center resistance, middle resistance, the current direction and my direction of traveling across that, again they both are opposite. So I can take that as plus 5I3 which equal to 0. Now let us simplify these expressions. Now let me explain this first. Minus 5I1 plus 5I3 plus 10I2 plus 10I3 plus 5I3 which equal to 0. Now add the like terms. So here I1 term is single, that is minus 5I1, and I2 terms also single, here it is plus 10I2, but I3 terms all sum up, you can get 20I3 which equal to 0. So if you can take it out minus common, and if you can rewrite that expression as 5I1, I wish I like to keep the first term as positive, 5I1 minus 10I2 plus minus 20I3 which equal to 0. Let me take a second expression. Now we were left with the third loop. So try to get it from this messy diagram. So now I need to consider the loop, the bottom loop, loop A, D, C, A. Loop A, D, C, A. So let me take a minute and I will draw that loop only so we can understand far better. Now this is the diagram of that particular branch A, D, C, A. Suppose in this branch if I am walking across the loop in this direction. So this is the direction of traveling. So it is clockwise direction. Now my direction and current direction across 5 ohm resistance, they both are same. So if it's both are same, I take as negative. So I can get that as minus 5i2. And when it comes to 10 ohm resistance, so again my direction and current direction across. So this is my direction in the loop and current direction, they both are again same. So here we can take again negative, minus 10 of I2 plus I3. Now in this case I am crossing the cell. I am crossing the cell from negative to positive. So if I cross the cell from negative to positive, so that I can take that as minus. So that is minus, I think I'll write that minus 10 at here. And again finally if I take this, I think it is plus. If I cross the cell from negative to positive, if I cross the cell from negative to positive, it is plus. So here it is plus. And if I cross this 10 ohm resistance, so this is 10 ohm resistance, my direction in the loop and current direction, they both are again same. Now here you can take that as negative. So here it is minus 10i, which is equal to 0. So let me write these equations properly as a single equation. So I got that minus 5i2 minus 10 of I2 plus I3 and plus 10 and minus 10i, which is equal to 0. Let me expand this. Minus 5i2 minus 10i2 minus 10i3 plus 10 minus 10i, which is equal to 0. If I take it out minus common and rewrite this equation, so that I can get as 10i minus 15i2, so sorry, here minus 10i minus 15i2 minus 10i3 plus 10 equal to 0. So we can take it out minus common, so that is 10i plus 15i2 and plus 10i3, which is equal to minus 10. Let me take as equation 3. Now solve these 3 equations. So what we got it, so I will put it at one place. So the first equation is (10i1 minus 5i2 plus 5i3). 10i1 minus 5i2 plus 5i3 is equal to 0, and the second equation is 5i1 minus 10i2 minus 20i3 which is equal to 0, and the third equation 10i1, it is 10i, it's supposed to be I, plus 15i2 plus 10i3 is equal to minus 10. So solve these three equations, and by adding, subtracting the three equations with one each other, try to find the current in the each branch. So finally you need to find the values of current, what is I1 and what is I2 and what is I3. So I1 equal to how much, I2 equal to how much, and I3 equal to how much, and along what is the value of I also we have taken one character, that is also I, and apart of that, what is the current across IBC branch equal to I1 minus I3, and across IDC branch equal to I2 plus I3. So try to find this all the values by adding and subtracting the above equations. I hope you can do that.